So 1/2, the denominator is a 2, so that's telling us to divide the whole into 2 parts. Why is there a 1 here? Because we're looking at one of the 2 sections. Does that make sense? Everybody get that? Thumbs up? Great, I love it. Good job. Okay, so my next question is, what do you think is going to be the denominator for the strip we just made? Gavin?
Maybe 1/4.
It's going to be 1/4, right? 1/4. So, on each of these parts, we're going to write 1/4. And why are we putting the 4 for the denominator, Gavin?
Because there's 4 sections.
Because there are 4 sections. And why are we putting the 1 on the numerator, Julie?
Because each is one of the 4 sections.
Each is one of the 4 sections. Great job. Let's see if I can get this one to stay flatter. It doesn't want to cooperate. Okay. So we have one more strip of paper. What are we going to do with it? Fold it. Okay, so we're going to fold in half. So that was like the first strip we folded, right? Now, like the second strip we folded, we're going to fold it in half again. Right, you got it? Good job. Okay. Now, we're going to fold it one more time to make it even smaller. So this piece ends up smaller than the other ones we folded, right? When it's all folded. Okay, we're going to open it back up. And what are we doing now?
Drawing lines.
Drawing lines. Which for me is the hardest part because I can't see them.
Miss Denny, are you blind as a bat?
I am blind as a bat. That was a great idiom to use there.
Isn't it if they're not exactly straight?
If they're not exactly straight, it is okay. It is for you. Okay, look at that one's got a lot of lines on it. How many sections are in that one? Oh, thank you for letting me know that was too low. Is that better? Can you see it?
There's 8 sections.
There are 8 sections. 1, 2, 3, 4, 5, 6, 7, 8, right? So, what is the denominator on our fraction going to be?
8.
8. And what will the numerator be? Each one of these is one section, right?
So 1.
Campers, the time is now 11:55 a.m. and registration will be closing in 5 minutes. If you haven't registered, you need to make your way to the library right now. Everybody else on campus, you need to start making your way off campus right now. We loved having you, but it's time to go home. Have a great weekend. Rawr.
Okay, has everybody got them? Great job. Okay. So, I keep getting them a little crooked. it, don't I? Okay, it's better, it's better. Okay, laying them out in front of you like that, what would be some of the things that you notice? Yes, Gavin?
For every fraction, it multiplies by 2 with the denominator.
Very good, right? So what Gavin is saying, he's saying here we have the denominator of 1 over 2. If you multiply 2 by 2, you get 4. You multiply 4 by 2, you get 8. Great observation. And so what happens when the denominator is getting larger each time?
Would that mean the fraction is getting smaller?
It's getting smaller. How do we visually see the fractions getting smaller?
Because it's getting into smaller and smaller pieces with the segments.
Because each time, notice that here we had 1/2, and then when we multiplied 2 by 2, right, we doubled it. Now notice that there were 2 spaces that had to take up that same space. So each unit is smaller. You notice that? Right? And again, when we multiply 4 by 2, right, there are these 2 of these spaces that equal the same as one of these, but they have to be smaller. Right? So the larger the denominator gets, is the fraction larger or smaller? Julie? Smaller. The larger the denominator, the smaller the fraction, as long as the numerators are the same. Right? So here's a little hint at what we're going to be doing tomorrow. Take a look at, notice how if we have 1/4, how do we get an 1/8 to equal the same as 1/4? What would have to be the numerator over the 1/8 to equal the same as a 1/4? Julie?
I think it would be 2 because it takes two rectangles of 1/8 to make one 4.
Right. So here it takes 2/8 to equal the same amount of space, the same as 1/4. And so we can write that. We can write 2/8 is the same as 1/4. Do you get that? You got that, Gavin? Thumbs up, thumbs down? Okay, great, okay. So what about if we're looking at 8s and we want it to be the same as 1/2? How many 8s would we need to equal the same as 1/2? Gavin?
We would need 4 in the numerator.
Right, 4. 4/8, 1, 2, 3, 4, is the same as 1/2. Do you see that? Here's 1/2. Here's, 1/2 here, right? Okay. Okay, so on your second sheet on your assignment, we've already done the first part, right? We're using the strips to represent halves, right? 4ths and 8ths. You're gonna write down, what do you notice about the number of parts or size of the parts? Right? You're going to make 2 observations. So we kind of talked about what is happening here, right? So what were some of the things we mentioned? We mentioned that as the denominator gets larger,